Okay, we'll talk about the Maximax rule. The Maximax rule is quite similar to the Maxi-Min rule. The only difference is instead of using a minimum of the rewards, we actually go with the maximum of the rewards. So for any given action A sub I, we find the reward that is the maximum across all states. And then we have a set of rewards that is the maximum for each action, and we take the maximum of the rewards that we have, and the corresponding action would be our optimal decision. The notation that I would use here is very similar to the previous video. I would highly recommend that you watch the previous video on Maxi-Min rule prior to watching this video, because I'm just going to gloss over the example because I'm going to use the same example that I used in the previous video. So this is the bakery example where the cost of a manufacturing cost of a cookie is 50 cents and the sale price is $1.50, and we sell by the dozen at this bakery, and the maximum amount of cookies that can be sold per day is 5 dozens, and the baker chooses to make up to a maximum of 4 dozen cookies, and that resulted in 4 actions in 5 states. And I defined A sub I is the action that the baker chooses to make I dozen cookies, and S sub J would imply that the bakery sells J dozen cookies. And we assume that the states are equiprobable, in other words, that the probability of these states are the same. They happen with an equal chance. So if state S1 would happen with a 20% chance, state S2 would happen with a 20% chance, and so forth, all the way up to state 5. Using the same reward function, we get the reward matrix as shown here. We have the rewards, they remain unchanged. The reward function would remain unchanged. The matrix remains unchanged. The only thing that is going to change here is the way we choose the optimal decision. So let's go ahead and do that. Since this is Maximax rule, for a fixed action we have to record the maximum of all the rewards that we see across all states. So let's go back to the reward matrix and find what is the maximum of the first row. So I'm going across all rewards for a given action across all states 1 through 5, and the maximum of all threes is just a 3. So I'd end up getting 3. Then I go to the second action and I go across all states and pick the maximum. The maximum of 6 and negative 3 is positive 6. In a similar manner, you could find that the maximum of the third row is a 9 and the maximum of the fourth row is a 12. So now we have found the maximum of all the rewards in the reward matrix across all J's, which is the states, which are the states, and then we take the maximum of the rewards that we have. So according to Maximax rule, we would have argument maximum of the maximum rewards. We already had the rewards, and it is 3, 6, 9 and 12, and the maximum of these numbers is 12, and we're looking for the argument maximum, which would correspond to our optimal decision. So which argument resulted in this maximum of $12? It was index 4 or action 4. You may either write it as 4 or you may call it as A4. They are one and the same. So the action is the optimal decision is that we use action A4. Well, by definition, A4 means that the baker makes 4 dozen cookies. The expected reward if the baker goes with this decision is $12. Now, there is also a disadvantage with Maximax. The result here is loss. Not that the baker is going to lose on an opportunity. The chances are that the baker would actually lose money because he ends up making 4 dozen cookies. But what if a customer does not order 4 dozen cookies per day and you just get an order for 1 dozen cookie or 2 dozen cookies? In this case, you are actually overestimating the outcome with profit in mind. But this might become disastrous. And why is that? So I end up overestimating. I end up choosing 4 dozen cookies, but what if every day I make 4 dozen cookies but I sell only 1 dozen per day? So the Maximax and the Maximin strategies are quite easy, but the Maximin is sort of underestimating the outcome, and Maximax is like overestimating the outcome. Now we want to find a perfect balance between the two, and that perfect balance can be achieved by using something called a minimax rule or the expected value rule when the probabilities are different. So in the next video I would explain the minimax rule. It's best that you look over this video carefully because I'll be using the same example with the minimax rule. Thank you for watching.